Hi, everyone. A very warm welcome to today's webinar on optimizing OpenBIM workflows for optimizing facade design. I'm Vanessa Tang from ACE PLP, also the Secretary of Building Smart Singapore, and I will be your host this afternoon. Today's session is brought to you by Building Smart Singapore as part of the ongoing OpenBIM Interoperability webinar series. It's a platform dedicated to promoting OpenBIM standards and seamless data integration in the built environment sector. For those of you who are new to this series, Building Smart Singapore is the local chapter of Building Smart International. Our mission at Building Smart Singapore is to lead the digital transformation of the built environment through the adoption of OpenBIM standards. And that's about promoting seamless data exchange, better collaboration, and more integrated digital workflows. Through webinars like this, Building Smart Singapore helps industry players explore innovative tools and approaches that support smarter and more sustainable outcomes. Today, we're going to be zooming in on one of Singapore's key sustainability requirements. This is the Envelope Thermal Transfer Value, or ETTV, which plays a crucial role in BCA's Green Mark compliance. As facade designs grow more complex, performing accurate ETTV calculations can be quite the challenge, but emerging tools and standards like IFC and simulation-based workflows are changing the game. Now, before we begin, we'd like to hear from you. Please take a moment to respond to our first Slido poll. So I invite you to take out your cameras to scan this QR code, or you can go on to slido.com and key in the code there, 1485601. All right. And when you do that, you'll find yourself in, let's see, in here. And I invite you to answer the first question, which is, how confident do you feel about performing ETTV calculations for your project? Tell us if you are very confident, fairly confident, somewhat confident, or not confident at all. So we'll be asking this question twice, once at the beginning of the webinar, just to see what everyone's baseline understanding is. And we'll be asking this again at the end of the webinar. So we'll see, if this session has helped you with a better understanding. And we'll also be asking you what are the factors, that would help you to make it easier for you to calculate your ETTV calculations. All right. Most of you are saying, a good 55% of you are saying you're not confident at all. It is complex and I struggle to get started. All right. I think this session hopefully will help you. Let's now take a deep dive into how simulation technology and open standards like IFC or industry foundation classes can be used to support sustainability goals, particularly in regard to BCA's Green Mark ETTV requirements. We've got two speakers lined up for you today. First, we've got Dr. Ruixin from BCA's Green Building Department, who will share insights on how national policies and research are enabling innovative green building solutions. And then after that, we'll hear from Dr. Alex Lee, who is the Managing Director and co-founder of BIM HVACTool, who will walk us through how simulation and IFC-based workflows can streamline ETTV calculations and enable performance-based facade design. Now, you can write your questions for our speakers anytime via our chat box, and we'll also have a live Q&A after both presentations. To kick things off, we're going to introduce our first speaker, Dr. Ruixin, a senior manager at the Green Building Department under BCA's Environmental Sustainability Group. With over 2 decades of experience in environmental sustainability and building technology, Dr. Lee has been instrumental in shaping Singapore's green building roadmap. Her research and policy work focuses on natural ventilation, thermal comfort, and urban heat mitigation, especially within our tropical climate. Now, Dr. Lee, can I invite you to turn on your camera and mic? Dr. Lee holds a joint PhD from the University of Singapore and Technical University of Denmark and continues to lead innovation at the national level. Please join me in welcoming Dr. Lee. Dr. Lee, the floor is yours.
Okay, thanks, Vanessa, for the nice introduction. Now I'm going to start sharing my presentation material. Okay, Ken. Okay, thanks, Vanessa, again for your opening address. So in this webinar, I will share with you the overview of ETTV regulation in Singapore and our perception in how digital solutions could help in facilitating the calculation of ETTV, therefore improve the overall productivity. So today's sharing from my part will cover following scopes. First, start with the background of ETTV and share with you the regulatory requirement about ETTV in Singapore. I will also give you a brief introduction about ETTV calculation and its key components. That could help you have a better understanding on the current challenges industry are facing regarding ETTV calculation. And lastly, talk about our expectation on how digital solutions could help to reshape the way of work in built industry and enhance our productivity. For the background of ETTV, as just introduced by Vanessa briefly just now, it is a performance index showing how well the building envelope was designed in terms of reducing heat gain of an air-conditioned space. The use of this index can be traced back to 1970s. By then, the concept of OTTV, overall thermal transfer value, was used to measure how much heat is transferred through a building's envelope. That is through the entire walls, windows, and roofs. Later in 2000, BCA and NUS reviewed this figure and worked out a more accurate version, which is now known by us today as ETTV, envelope thermal transfer value. ETTV is being used to estimate the heat transfer through external walls and glass windows into an air-conditioned space. Built industry is now using it as a scale to assess whether the design of a building envelope could sufficiently reduce the heat gain. It is important to design the building envelope with low ETTV to reduce heat gain through walls and windows for an air-conditioned building to reduce the energy wasted on cooling, especially under the condition of such a hot and humid climate condition like Singapore. Reducing ETTV could lead to reduction in energy consumption for air conditioning system and contribute to achieve the carbon emission reduction commitment made by Singapore in COP29. Currently, in our regulatory requirement about ETTV, the content is being stated in the Code for Environmental Sustainability of Buildings. The current version is edition 4. In Singapore, all new buildings and those making major retrofitting works exceeding certain GFA must comply with ETTV standards. The ETTV for air-conditioned non-residential building should not be higher than 45 watts per square meter. These requirements form part of our national strategies to create more sustainable and energy-efficient buildings. And beyond the code for environmental sustainability of our buildings, an even higher benchmark for ETTV was set in Green Mark requirements. With project with Gold Plus and above ratings, the ETTV shall not exceed 40 watts per square meter. This is a formula of ETTV. It gives you an overview of the key components of heat transfer through building envelope. The ETTV calculation considers three main components: heat conduction through the opaque walls, heat conduction through glass windows, and the solar radiation through glass windows. The formula takes into account various factors, including wall thermal transmittance, glass thermal transmittance, window-to-wall ratio, solar heat gain coefficient, as well as the impact of the orientation of a building facade, which taken in this equation as a correction factor for solar heat gain through fenestrations. Each of the components is weighted differently based on its impacts on overall heat gain. And then the overall ETTV of a building is an area weighted average value of the entire building envelope. So from this slide, from the formula you just saw, you may have had a sense on the toughness of delivering the ETTV calculation. The example given in this slide shows the necessary works needed for ETTV calculation. This case by itself is a very good example, shows how a low ETTV is being achieved. This project used a double low E glass and used a corridor as an effective shading design. So altogether brings a shading coefficient down to as low as 0.24, and whereby the ETTV can be lower to 33.5 watts per square meter. However, in order to get an accurate figure of ETTV, the consultant usually need to spend a lot of effort in marking out the different parts of the building envelope for the detailed calculation, and need to make sure that the correct heat transfer value and solar shading coefficient are being used. The whole process is usually done through manual calculation, which is quite time-consuming and inevitably will bring in human errors. Every changes in the building design will require recalculation, which can lead to project delay and bring the coordination challenge among different stakeholders. Additionally, verifying the calculation during the submission and approval process can also be a very cumbersome task for us as regulatory authorities. So it is undeniable industry are facing great challenges currently when they conducting the ETTV calculation. And if the industry still stick to the manual calculation, we can imagine with the surging cost of manpower, the current way of work is not sustainable anymore. And we should thank for the development of technology, which can lead us out from this old hard way and raise the possibility to solve the issues with digital solutions, which might bring the benefits like make the calculation automatically and give us a real-time result by just a click a button. And the designers can try out many different design patterns and come out with the most optimum result with lesser time spent. With improved productivity, each stakeholder can practice on more effective aspects instead of wasting their time on manual calculating and checking. And surely this will make the collaboration across the team more effective. When talking about the future development of digital tool, especially for ETTV, we can imagine if the digital solution provider could provide the following breakthroughs, such as using automated calculation tool to integrate with our BIM model, make it a cloud-based platform, allow for real-time collaboration between architects, engineers, and authorities. And with the development of AI tools, will it be possible to work out a more efficient way based on the machine learning algorithm to optimize the building design for ETTV, not only for compliance, but also for the best performance design? And if the digital solution could help to save the time in its submission and streamline the verification system, it will expedite the approval process. So all these solutions will not only reduce the calculation time and errors, but also facilitate better decision-making in the very early design stages. Of course, I have to admit some of it may look quite bold as of now, but given to the fast evolution of AI technology, IT technology, we believe the digital service providers soon could be able to provide a much advanced tool to build industry, thus facilitate the new generation of industry transformation. And with this comes the end of my part of sharing. I will pass the speaker back to Vanessa. Thanks, everyone.
Thank you, Dr. Lee, for those important insights into the regulatory requirements, challenges, the ETTV formula calculations, and also for your vision of how digital solutions can support sustainable design in Singapore. I think your work lays the foundation for tools like BIM HVACTool to thrive in real-world projects. And now we're going to move on to the technology side of the conversation. Our next speaker is Dr. Alex Lee, the Managing Director and Co-founder of BIM HVACTool. It's a platform that empowers AEC professionals like us with advanced simulation and building performance analysis capabilities. He's got over 25 years of experience and a pioneer in integrating computational fluid design, digital twins, and urban climatic mapping into design workflows. Under his leadership, BIM HVACTool has been adopted by institutions like the National University of Singapore, Sabana Jurong, and Atelier 10. Today, Dr. Lee is going to show us, the other Dr. Lee, Dr. Alex Lee, is going to show us how IFC-based simulation workflows can improve ETTV computation and enable performance-based facade design in line with the BCA Green Mark requirements. Please welcome Dr. Alex Lee. Dr. Lee, over to you.
All right, so based on what I have given today, the topics of my presentations will be on the use of my software, the BIM HVACTool, to enhance sustainable design workflow with advanced simulation, BIM HVACTool, and IFC integrations. All right, as Vanessa had mentioned, all right, we have actually developed a software for building performance analysis for a long time. So today is the first time that we give such a talk in public. All right, now basically, I think I cannot overemphasize the importance of ETTV. All right, in Singapore, it has gone a long way. All right, back I think long time ago, I think the terminology is called equivalent thermal heat transfer, but somehow along the way it has been changed to envelope thermal transfer value. So basically, it's ETTV, RETTV, or RTTV that we are talking about today. Now, the importance of ETTV is not just actually happen in Singapore, but in tropical countries like Malaysia or Indonesia. All these countries have one form or another of ETTV. All right. In Singapore, we changed from OTTV to ETTV, right? Because our researchers are more advanced, especially Prof. Chow and NUS team of researchers. They actually look at it in a very serious manner. So they have basically make use of the solar data. Sorry, are you guys able to hear well? Just want to have a
yes,
sound
we
check.
can. It's perfect.
Okay. All right. So the Prof. Chow and his team has actually spent a lot of efforts in getting the ETTV correct. And our solar data is actually not just being adopted by our own ETTV, but at the same time, is actually adopted by Indonesia OTTV as well. So if you want to know about the details, all right, maybe buy me a cup of coffee and then we can go through, right, in some other time. Now, so today's topic is on Singapore ETTV. Now, in the Energy Modeling Guide of Green Mark 2021, actually they also mentioned about ETTV, and ETTV is required to compute for both the proposed model as well as for the reference model. So if you look at it based on Energy Modeling Guide, all right, that is referring to the ETTV guide code of conduct. So basically, the guide, you know, it serves as the so to speak the Bible of ETTV calculation. Now, there are a lot of details in that guide. It's not so simple because it has a lot of table in terms of solar table, in terms of SC2 table. So if you do not have gone through a proper training, you may be using the right table or you may adopt the calculation wrongly. All right. So this is just one word of cautions. Now, when it comes to do a baseline calculation, okay, all right. This is debating, but anyway, I just want to flash through. I'm not going to argue about it. Now, ultimately, the baseline model is what you try to achieve, 45 meters per second, per meter square. But for the Green Mark proposed calculations with the current BCA requirements is quite high now. So it's either 38 or 40. It depends on what kind of classification you want to get. Now, today's talk is not so much about all this, you know, figures and things like that. But I want to quickly go through this set of notes, PowerPoint, and then show you a demo about what our software can do for ETTV. Now, as far as the technology is concerned, at this moment, we have two methods. which is based on OpenBIM solution. One method, the first method is called standard table lookup. So for those of you who are familiar with ETTV calculations, basically you know what I'm talking about. Basically, you have to flip through so many pages to get one value out, which is the SC2, right? And this SC2 is very much depends on the shading device type and depends on the glass orientation and so on and so forth. So that is the reason why a lot of people find that it's very tedious. All right. So I have this summary page to talk about what is the difference between standard table lookup and performance-based SC2. The current BCA guide actually is only catered for 4 kinds of shading device. All right. Horizontal, overhang, vertical fins, it creates, or maybe some no shading. All right. Now, and then what's performance-based? Performance-based basically is catered for non-conventional type of shading device. All right. It's not just referring to shading device. It could be building shape. I mean, the so-called the facade design. So as far as, you know, maybe some people is not aware what is performance-based. Basically, performance-based is nothing more than getting the correct shading coefficients. All right. So in the BCA ETTV guide, there is some illustrations on how to compute the correct SC2. All right. So our method of performance-based module is basically based on this. All right. I will show you exactly how we compute this SC2 accurately, all right, in a little while. So just be patient about it. Now, it has come a long way since 1979. Now, the pain point is already made known to many of us, right? Every time we talk about this, people know that there are a lot of issues. Architects especially, they find that it's very inaccessible to the ETTV calculation based on spreadsheet. Now, the important thing of the motivation behind our software is basically highlighted in this slide. So I will not so-called dwell on this one, but I want to quickly go through the workflow so that you know exactly what you can do. All right, what are the troubles that you are, or hardship that you're going through? All right. Now, this is a table. All right. Actually, somebody has published a paper, so I just grabbed that table because actually this describes the exact workflow of the ETTV calculation in the industry at this moment. Basically, you have to use the AutoCAD to extract the area, to extract out certain informations. And then the U value of wall, you basically have to compute and then put in the spreadsheet. Same thing for SC1, SC2, everything is actually applied on the spreadsheet. Now, to the older generation, they may say that, hey, ETTV calculation is a piece of cake. All right, yes, I agree. In the good old days, when the buildings are not, have many glass panels. All right, why? Because if you know the so-called the formula of ETTV, all right, you look at it. The first 2 terms actually is conduction through the wall, conduction through the glass, and there is no orientation of glass panels come into the pictures. And therefore, as long as you know the UW, if you know the U of value of the glass panels, that's it. You can compute ETTV, all right, for these 2 components. But if you have started to have glasses, okay, windows, they have different orientation. Sorry, the radiations component, the solar heat gain through windows, through radiation start to kick in. As a result, all right, the method of BIM HVACTool is nothing more than this. All right, we combine the 3D model, which is come from, we can get it from Revit in the form of IFC model or maybe SketchUp model. All right, because what we really need is the geometrical details of the model, and then one is combined with the material. We use a material to construct the wall or maybe the windows, and that's it. We have all the things that we need. Now, formula is nothing, so the tools can be used to compute very complex so-called geometry. All right, for example, this mall, Sabana Jurong campus, all right, is done by us as well. All right, and there's some other so-called complicated building with different, very fanciful facade as well. All right, now the code has been validated using BCA example. For those of you who have gone through ETTV 3 learning, you know that what is Appendix D. All right, that is a commercial building. Right, we created the IFC model from scratch, and then put into the Revit model, and then export in IFC, so we can get all the geometry out. Okay, now we will be sharing this PowerPoint to you, so not to worry. Now, so basically, there are so-called we have actually spotted some so-called minor error, so we have just highlighted. So hoping that actually all these finding can be reflected in the guide in the futures. Now, beside ETTV, the software can compute RETV, which is for residential. All right, so let me quickly fast forward, and then I'll show you exactly what we want to do today. All right, let me fast forward. All right, the example that I want to show it to you is this one. Okay, this is a hospital project. All right, we got the IFC model from, we downloaded from the web. Okay, so basically the whole process is like that. We import the geometry in. Okay, and then you start to do some organizations. All right, so the first thing that you want to do, all right, is to group it. Okay, now I will highlight some important features. Then after that, I will show a live demo. Now, for this particular IFC model, all right, the architect or whatever, the BIM modeler actually put in some more effort. They actually have created the constructions. Now, if you look at the lower sections of this table here, all right, for a particular basic wall exterior, this particular construction was captured. They have captured the layers, all right, they even captures the thickness of each layers, but unfortunately, this conductivity, the material properties are missing. Okay, as such, the U value cannot be computed correctly. Okay, so basically, you can get the correct material property, enter into the system, immediately you can get the U value of the particular piece of wall. All right, so this is exactly what our software can do. All right, if all this material property or even the thickness is not available in the model, not to worry about it. As long as you know the layers, you can update and then change the thickness and get the correct conductivity from a database. Bingo, you can get the U of any wall you want. All right, so now the first thing that what you will need to do is window. I'll explain in detail why you need to sort things out and starting from windows. Now, like I mentioned before, the radiation through the windows is very, very high compared to all the opaque wall or compared to glass through conduction. Now, there are some issues with 3D modeling of windows. All right. So your first task after we importing a 3D model, be it SketchUp or be it IFC, all right, using a software, you can actually look for all the windows, external windows, and then regroup them. For example, like I have selected all the windows, right? And then I group them. Now, so these are all the windows of your part of your projects. All right. So you know ETTV. You know that you have to regroup so that these windows of different shape, of different size and different orientation must be properly grouped together. Otherwise, you won't be able to get the SC2 correct. So the first task after you regroup it, you basically do is to separate them again. The north-facing windows, you have to separate north and not facing the north. The south, you have to facing the south. All right. So go on and on. Okay. Now, I basically just highlight to you that for one particular facing of the glass panel, after the separation, this is what you will get. Okay. Now, if I zoom in this group of glass, all right, you realize that, as a BIM modeler, you know what I'm talking about now. The glass that you have selected is not just one surface, because the glass is a solid element, it's a solid model, so it contains 6 patches. One facing north, forward facing, backward facing, left, right, top, and bottom. So your first job after doing this is that you have to separate them so that your your outermost skins can be extracted out. Okay. Now, so once you got the so-called the glass extracted out, that is where all the actions start, because now you have all the building element that you want. Okay. Now let me switch over to my demo so that you can get a feel of it. Ultimately, what we really want is to change the construction. You know, we are so used to this kind of nomenclature. F01 for fenestration, F02 something like that, and then maybe some opaque wall like that. All right. So this will contain all the different layers. Now let me switch over to my demo. All right. I have prepared a lot of cases for you. Let me just put in the stage 1 for you. All right. I'm hoping that you guys can see the screen at this moment. All right. Now this one is basically done after I have extract out the windows. Okay, you see my windows I have extracted out. Okay, now so what happens? You know, if you rotate the building model, if you select the outer skin, okay, all right, you only pick up the outer layers. All right, so this is very important because you need to compute the SC2 on these glasses. Okay, now then after that you have to apply the constructions. Now, for example, like this one, okay, all right, this one at this moment I have not applied any construction on it. I have not applied any construction on it. All right, so let me turn on the construction view. All right, remember just now I told you when I import the model, all right, there are already some inherent constructions already, but for the glass, this is my own so-called geometry. All right, it still remains as gray color, meaning that this is a default. There's no construction detail to it. All right, so ETTV calculations. All right, the consultant has to put in certain value. All right, for example, like if this one's you want to use certain value. Okay, let me change it into glass. All right, I will go to the construction detail. I'll go to construction detail. Okay, so you see, I have a bunch of maybe some construction. All right, now so every single group actually represent one type of glass. So I have different SC1, I have different U value. Okay, so if you decided to say this group of glass is of this type, after you select the glass, you simply assign, all right, and the constructions will be applied onto the glass that you want. Okay, so this piece of glass that I have selected, all right, is blue. So if I switch over now, all right, it's blue color. Okay, meaning that this has been take on the constructions that you want. Okay, now same thing for opaque wall. All right, let me show you the complete model. Let me show you the complete model. This is stage 2. This is the okay, this is the complete model. Right, so I have applied all the construction detail onto this model already. Okay, now if you look at my grouping on the left side, now I have a very nice grouping. All right, the one that I click is actually central block is glass 2. Okay, all right, so if I rotate, all right, immediately I know what I'm talking about. Okay, this is a group of glass that I name it that way. And if let's say you have some other grouping, for example, like the east wing, all right, if you click on L1, L2, east wing, south facing wall or south facing glass, all right, you see these are the opaque wall. Okay, so now the name is very important because at the end of the day, when you do calculation, you also have report ETV value that associate to get with a particular group of opaque wall or glass you want to know. Now, so I color code it so that you can see a very nice way of the building look like. But if you want to refer to the material or maybe the so-called the constructions, if I switch over to construction color, all right, I'm switching over now. Okay. Now, so these are my construction color. Can you see that? All right, it's different from the geometry color. The color is different because this construction color actually are associated with some material and construction detail. All right, so for this particular exercise, I have only put in some limited number of so-called choice. Like I have two type of fenestration, F01, 02, and then the opaque wall, I have yellow G2, green G1A. So now, so immediately, if you put in for example, like G2, okay, G2 is actually not glass, actually it's an opaque wall. So if you look at our database, now our database consists of two kinds of database. One is material, which is opaque material. If you click on opaque material, we have a lot of database. All right. So we have brick, we have cements, we have many type of material. All right. So some of them may not be exactly the same as your project choices, but never mind. You can recreate, duplicate, and then key in the value of conductivity, the density, and the capacity of your choice. Now, for constructions, okay, same thing for glasses as well. We have material, but constructions we also have two. So let's look at the opaque wall. Okay, the opaque wall, for example, like we have, the one that we use is, let's say G2. All right. No, G2 is actually a glass, but W1. Okay, so W1SM. Now this is W1SM. It's opaque wall. Now you see the layers, right? The material layers is actually captures here, right? Captures here. So the thickness is also, you can enter, all right? If your IFC model does not capture it, you can update here. Now the conductivity, the density, the capacity are all come from the material database. All right. So the moment you choose the layers type, the material, you update the thickness, immediately you will the software will compute the U value for you right here. Okay. All right. Now, so later on, if you have any question, we can come back here. So if you decide not to use W1, basically you can pick, just say, okay, W1, this ones. All right. You just simply select the wall that you want to do. For example, you want to change the wall type. Okay, this one. You select a different constructions. You simply click assign. Immediately you get updated immediately. Therefore, if you're going to compute the ETTV, the value will be different because now this particular wall is not the same anymore. It's of different construction. Now, for standard ETTV, okay, then how do you compute ETTV? Now, so we have all the construction detail apply onto the facade that you want. Basically, it's the same thing as what you are going through with so-called the spreadsheets way of doing things. But on our software, we have added one thing. Okay, now remember, ETTV is only applicable to air conditioner space. All right, if those the space that is not air conditioned, you don't have to do anything. All right, so how do we control these kind of things? All right, in our software, we have included an attribute called ETTV flux. Okay, ETTV flux. What does it mean? It means, all right, all the blue patches, wall or glass panel that you intended to include for ETTV will be computed. All right, so this is one way. All right, a second so-called defense. You can, if you think about it, all right, or rather to eliminate, all right, so-called get rid of those areas that you do not want. For example, like from this particular inspections, you can also check. Maybe you make a mistake. For example, you see, how come this particular area is not black blue? Okay, so this could be a mistake. All right, or maybe you can search around and then see what happened. Okay, maybe there's some other mistake. So this is another way to make sure that your surface patches are accounted for. All right, so this is important because once you have done this particular one, you can pick the glass now Okay, you can pick the glass now. Now, why we want to do this now? Because now we need to apply SC2. All right, SC1 is belong to material for the glass panel, but now we need to apply SC2. SC2, it depends on orientations of the glass and also the kind of shading device that the architect has so-called implemented. So if this particular one do not happen that to have a so-called shading device, but if you want to do that, okay, all right, if you want to do that, you can actually apply some SC2 on it. Okay, so you look at on the screen. Now you have to apply fenestration SC2. So the SC2, you will pick what you want. All right, as I mentioned before, the software caters for 4 different shading devices: horizontal, vertical, overhang, and 8 crates. Now, for standard table lookup, you don't even need to put in the shading device in the model because the SC2 is prescribed. It's lookup. So the table below here, the value that you get is basically digitized from BCA guide. And if you look at it, all right, every single group actually have an orientation. All right, so it happened that the software picked it automatically. So this particular so-called group of glasses are facing north. All right, so on and so forth, you apply SC2 if you decided to use the standard table lookup. But in the event that, hey, your building is very complex like this one's, all right, you know that shell shading is needed to do the job correctly. All right, so now you have to use performance-based SC2. So performance-based SC2, you have to get the correct sun path diagram. All right, so let me turn on the sun path diagram. Sun path diagram, right? Sun path diagram out. Okay. All right. So you have to key in the right, correct longitude, latitude, and then so UTC as well. All right, and then so you have to perform simulation. So in other words, first of all, you have to select all the patches that you want to include for ETTV calculation, like what I'm showing here. Okay, all right, and then you do ETTV calculation. All right, so there is an option here. There is an option here. If you are going for standard table lookup, you just click this one. If you are going for sun path action script, which is a performance-based simulation, you select this one. And then you retrieve the script that we have already programmed it. So this is a script. All right, now look at this. For the shadow coefficient exercise that mentioned in BCA guide, basically you have to go through this process. March 21st, June until September 22nd, and then the simulation time is from 6 p.m. to 7 a.m. to 7 p.m. All right, so this is exactly what we did if you look at my PowerPoint. All right, you look at the PowerPoint, we perform some path simulations, we get all the rays shooting on all the glasses. All right, so if you look at the glass panel, now our glass panel is actually digitized into very fine meshes. Why? Because shadow is unpredictable. You do not know which part of shadow on the glass. So you cannot just simply represent the window panel as 2 triangles or one single rectangle. But because based on the so-called the total radiation that we have computed, you realize that, hey, you know, the value of total radiation is not the same, even though you have the same, same orientation. All right. So this is a bonus if you do performance based, because you can get the total radiation out. But ultimately, if you're not interested in total radiation, no problem. At the end of it, we get the ETTV out as well. Okay, this is the ETTV, right? So it's very so-called clear to tell architect, what is the high value of ETV on a certain piece of facades. All right, and more importantly, our software can actually produce a BCA compliance report at the end of the simulation. Let me just show you now. So this is stage 2. Let me just get the right one. This is what? This is stage 2, stage 3. This is this one. Where is it? Okay, never mind. Basically, if you finish your simulation, all right, you can click a button like this one. Where is it now? Okay. Okay, because I did not select anything, I need to select front side. Now, you see a button here. Second, coming to the end of the presentation already. So let me just quickly sum it up. I select all the front side. Oh, this stage 1, sorry, this is not done properly. This is stage 2. Where is my correct project file? Yeah, this one. Okay. All right. Now, you see the bottom at the so-called this menu bar here. There is a report. So all the value of the SC1, SC2, the SC, even the correction factors, it's all tabulated in the summary page. But if you click on this report, all right, we will produce a BCA compliance summary. All right, and if you feel comfortable, you can just simply upload it to BCA and submit it, or maybe you can do some editing, change your company logo and address, and present it to your client and go for a review. All right. So yeah. So you see the report actually produce a page like that, not just a page, pages of report. All right. So that you can actually, you can actually check whether there is some things that you need to amend or not. All right. So I end my presentation here, but before I end, let me just mention about the summarize my talk. 1 second. How come I cannot do it? What's going on here? All right. Now, the simulation part, okay, is quite simple. As long as you set it up, you can do ray tracing, and then you just kick back and relax. Okay. All right. And at the end of the simulations, you get all these nice graphics to display. All right. Of course, with the report. For this particular case, I did it this morning. All right. Again, I did it one more time. So the simulation time is less than 2 hours. So if you put all the so-called if you include all the efforts, maybe this project can be done in less than 2 days. Okay, less than 2 days. Okay, so I guess I can end here. So I would prefer to have more question and answer. And then if you have any questions, you can actually raise it so that I can address your concerns immediately. All right, through the GUI. All right, Vanessa, back to you.
Thanks, Dr. Lee. That was a great and very detailed walkthrough of how simulation and OpenBIM can come together to transform sustainable design workflows. Okay, one of the things that I wanted to share, with everyone is also that Building Smart Singapore has a digital solutions directory. What you can do is to go over to Building Smart Singapore's website. Right, this is our homepage, buildingsmartsingapore.org. Go on to resources and you will find solutions directory. And this is a list of, various kinds of digital solutions that are available, for you to use and to consider. Just a reminder that Building Smart Singapore is a not-for-profit organization, and we do not recommend any of the solutions in here. The objective of us posting these solutions online is to just help you to cut short that research process and just to give you an overview of what is available out there right now. You please do your own research as well when it comes to looking through these digital solutions and deciding what works for your project team. All right. So
basically, Vanessa, the message they're asking is actually whether the presentation slides will be made available or not.
Yes, the presentation slides will be available, and the recording will also be on Building Smart Singapore's YouTube channel.
Okay. All right. Thank you so much.
Now,
Thank you.
on behalf of Building Smart Singapore, thank you all of you for joining us, and we hope to see you at the next session of the BIM Interoperability series. Until then, take care and stay inspired.
All right. Thank you. Bye-bye.
Thank you. Bye.